A follow-up to the product rule of derivatives is the quotient rule of derivatives. So if we have a function that could be written in the form f of x over g of x, that is, we have a clear numerator and a clear denominator, we can find the derivative by using the formula here, which is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So in this example, I have y equals 3x to the fourth all over sine x. So the numerator is 3x to the fourth and the denominator is sine x. So if I want to find dy dx, or the derivative of the whole thing, first of all, I'm going to label which of these is which. So here's my numerator, here's my denominator, and I'll find each of those derivatives separately. So f prime of x would be the derivative of this numerator, which is going to be 12x to the third, and the derivative of this denominator, g prime of x, the derivative of sine, is cosine. So now I'm going to apply the quotient rule, which says the derivative of the numerator, already found that, times the denominator minus the numerator, so the numerator would be 3x to the fourth, times the derivative of the denominator, all over the denominator squared. And there we go. All done. So we can use the quotient rule to find some other derivatives that we haven't been able to do before. So, for example, we have not memorized the trigonomic derivatives for secant, cosecant, and cotangent. I'll just do a couple of these so that we can see. So we're going to use the quotient rule in order to figure out what the derivative is for secant. So the first thing I'm going to do is write it in terms of cosine, because I know the derivative of cosine. So this would be my numerator, and this would be my denominator. So f prime of x, the derivative of the numerator, is 0, because the derivative of a constant is 0, and g prime of x is the derivative of cosine is negative sine. Okay, using the quotient rule, which is this, and this is g squared, and this is dy dx. So dy dx is going to be 0 times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So the first term here is negative, and I'll get a sine x in the numerator and a cosine squared x in the denominator. So this is the answer. We might simplify that a little bit more by writing it as, we could split it up as sine x over cosine x times 1 over cosine x, which would be tan x times secant x. Okay, so there's the answer, but we could have left it like this. Doesn't matter. Okay, let's take a look at cotangent. Okay, so cotangent, there are actually two ways that we could do cotangent. So we could do cotangent as y equals cosine x over sine x, or we could do it as y equals 1 over tan x. Either way is fine. I'm going to elect to do it with, it doesn't matter. I'll do the one on the right. So f of x is going to be cosine, g of x is going to be sine. So I'll write that right here. F of x will be cosine x, g of x will be sine x. So the derivative of cosine, still negative sine, and the derivative of sine is cosine. So it's going to be very easy to get lost in this, so we'll want to be very careful. So we have y dy dx is going to equal. So the derivative of the numerator is negative sine x times the denominator, sine x, minus the numerator, it's cosine x, times the derivative of the denominator, all over the denominator squared. So let's see here. We get negative sine squared x minus cosine squared x. Now, if we were to factor out a negative, we could rewrite that as 1, which we'll do here in a moment. So factoring out that negative, we get sine squared x plus cosine squared x all over sine squared x. And we can then go ahead and rewrite that as a 1, so equals negative 1 over sine squared x. And we could bring up that sign and write it as cosecant. So the derivative of cotangent, so if I did dy dx right there, is going to equal negative cosecant squared x. There we go. Good. All right, going on. Bunch of random examples of the quotient rule. So let's work through them. So here's my numerator, here's my denominator. So the derivative of my numerator is going to be negative sine x, and the derivative of my denominator is 10x. Okay, so it's going to be this. It's good to just kind of write what we're doing right here. So the derivative of the numerator is negative sine x times the denominator, 5x squared, minus the numerator times the derivative of the denominator all over the denominator squared. So we can simplify this down a little bit, so I'll write it a little bit neater. So we have negative 5x squared times sine x minus 10x cosine x all over, and if we square that, that would be 25x squared. We can reduce by dividing all those by 5 and by an x. So we get negative x sine x minus 2 cosine x, because we can cancel one of the x's, all over 5x. There we go. All right, this one. Here's our numerator. So f prime of x, I'm taking this derivative. I get 14x squared, no, 14x plus 5. And then the derivative of the denominator. So this would be x to the 1/2. So that's going to be 1/2 x to the negative 1/2, which we could write as 1 over 2 root x. So there's going to be a lot of little simplification that we can do with this one. So we're going to want to be very careful. So our derivative is going to be 14x plus 5 times root x plus the numerator, 7x squared plus 5x times the derivative of the denominator is 1 over 2 root x. I'm glad we aren't doing this with limits. It'd be a bear. And then our denominator squared, so that would be x. Okay, so it looks like we can't cancel any x's. We could distribute that right there. I don't really know that is worth it, but I'll go ahead and write it anyway. We would get 14x root x plus 5 root x plus 7. Yeah, I'm quickly thinking that it actually is not really beneficial at all to do this. We could technically simplify this piece right here and that piece right there, but I'm actually not going to bother. So I'm going to say that that was probably good enough right there. Okay, so as we go along, we'll get a little bit more complicated. So I'm going to not really do example 4. I think that's easy compared to the other examples, so I'll do example 3 right here. So our numerator is f prime of x, sorry, is going to be, so this could be x to the 2/3. So our derivative will be 2/3 x. I'm going to decrease that exponent by 1. So negative 1/3, which equals 2/3 over cube root of x. A little bit sloppy right there. All right, and g prime of x is going to be 12x squared minus 10x. So using our quotient rule, the derivative of the numerator, so 2/3, this is a cube root of x, because I moved that down, times the denominator, so times 4x cubed minus 5x squared, minus the numerator, so cube root x squared, times the derivative of the denominator, that is 10x, all over the denominator squared. So definitely expanding the denominator is not going to be helpful. We could distribute in our numerator, so I'll go ahead and do that. We could rationalize, but I really, again, don't think it's going to be worth it. I could distribute that. Why not? All over the denominator squared. And I don't think it's really necessary to expand that out. It's not going to help us any. So could do this one, but it's pretty simple compared to the other ones, so not that big of a deal. All right, so last two. Now, these are going to be fairly involved. And the reason they're going to be involved is because our numerators in each of these cases is a little bit more complicated. So if I take a look at, say, this numerator, and I start to take its derivative, notice that I have 5x squared sine x. This is a product rule. So sometimes when we're using the shortcuts for taking derivatives, we'll have like product rules within quotient rules, and we'll get to it soon, chain rules, and they all might be mixed together. So we're going to need to separate them out. So when I'm doing this derivative, I need to remember my product rule, which says that if I have something like this, two things multiplied together, I'm going to do the derivative of f times g plus f times the derivative of g. So it's very similar if we take a look at the quotient and product rules. Our product rule is right up there, and our quotient rule would be essentially f over g. And if I want to take that derivative, I'm going to have this. So notice, very similar, just we do have this g squared at the bottom. Okay, so what are we going to do here? Well, we are going to go ahead and do the product rule on the numerator. For now, I'm going to ignore the denominator because I want to just find that derivative all by itself. I'll work over here because it'll be easy to delete it out. So, using the product rule on it, I'm going to say that the first thing is 5x squared and the second thing is sine x. And the derivative of the 5x squared is 10x, and the derivative of cosine, or derivative of sine, is cosine. Okay, so, which means the derivative of this thing is 10x sine x plus 5x squared cosine x, using my product rule. So, over here on the left, I'm going to go ahead and write that in. Now, using all F's and G's, this could get a little bit confusing, but know that I am just separating them out. So F in this case is this numerator. That's what I'm talking about. And that derivative was all of this stuff that we found over here, which is 10x sine x plus 5x squared cosine x. Okay, now our derivative of our denominator. This is our denominator. That's easy. The derivative of that is 6 and nothing else because the derivative of that 4 would be 0. So now, using my quotient rule, just get rid of all that, we're going to say our derivative is, so the derivative of the numerator, big long thing, and then times the denominator. It may or not be worth multiplying that out. We'll see here shortly. Minus the numerator times the derivative of the denominator. So I'm just going to go ahead and skip a step, and I'm going to say that right here, instead of a 5, we'll just put a 30, because the derivative of the denominator is 6, so we'll just multiply that right away. Save a little bit of work. And then the denominator squared, so 6x plus 4 squared. And really, we could just say, here is the answer, and not do anything else. All right, this last one. So same problem as was over here. So my numerator is actually going to be a product rule in and of itself. So I'm just going to go ahead and do that. So applying my, and I'm going to say that's how I'm separated, 2x and tan x. So applying my product rule to the numerator is going to give me 2 tan x plus 2x secant squared x, and the derivative of my denominator is cosine x minus 8x. So using the quotient rule now, is going to be 2 tan x plus 2x secant squared x minus my numerator, so this is going to be a little bit lengthy, 2x tan x, derivative of my denominator, sine x minus 4x squared, all over denominator squared. And I'm not going to multiply out that denominator. That looks fine to me. Pretty good. All right, that wraps up the quotient rule. Note, these two things, very important. They pop up frequently. And do look for product rules within quotient rules or quotient rules within product rules. You may need to do several different derivatives in order to get your final answer.